We've spent the last few weeks learning several different ways to compare fractions. We've learned that you can look to see if the denominators are the same. So 2/8 compared to 4/8, we can just really think about the number of pieces because the eighths are the same. When the denominator's the same, we can just think about the number of pieces. So 2/8 means that there are 2 pieces. 4/8 means that there are 4 pieces. They're all eighths. They're all the same size of piece, so 2/8 is less than 4/8. We've learned that you can look at the numerators and check to see if they are the same. When they are the same, we can just look at the denominator and think about which piece is bigger. So I know that fourths are bigger pieces than sixths. 3 of the fourth pieces would be bigger than 3 of the sixth pieces. So 3/4 is greater than 3/6. We've also learned how to really think about the size of the fractions and to compare those fractions to our benchmarks, 0, 1/2, or a whole. That's a great strategy that can help us compare two fractions. So for example, I know that 8/10 is over 5/10, so 8/10 is over a half. In fact, it's pretty close to a whole. It's just 2 pieces away from a whole. And I know that 2/6 is just 1 piece less than the half. So we have one fraction that's greater than a half and one fraction that's less than a half. So without even drawing a picture or using fraction bars, I can tell that 8/10 is greater than 2/6. Sometimes you'll have two fractions that are so close to each other that it's hard to tell. For example, 4/6 compared to 9/12. I can see they don't have the same denominator. They don't have the same numerator. Let's see if we can use a benchmark. 4/6 is just a little bit over the half. It's 1 piece over half. And if I think about 9/12, it's also over a half. 6/12 equals a half. So these fractions are both over the half. What makes it tricky is that sixths are pretty big pieces compared to 12ths. 12ths are really small pieces. So I'm not sure because 9/12, there's 3 extra 12th pieces past the half. I'm not sure. Those are really, really close. So there's one more strategy that we're going to learn today that will help us to compare these fractions. And that strategy is to create a common denominator. If you look at the 6 and the 12, think about how those numbers are related. You may have noticed that 6 is a factor of 12, or you may have been thinking 12 is a multiple of 6. This is perfect for creating a common denominator. We can take 4/6 and we can change the name of that fraction amount. So I'm going to multiply it by 2 halves. I know that 6 times 2 is 12. So if I multiply it by 2 halves, then I will get a fraction with a denominator of 12. So 4 times 2 equals 8, and then 6 times 2 equals 12. I've just found a fraction that's equivalent to 4/6. But it's really great because it has 12 as a denominator. And so now I can easily compare the two fraction amounts. I know that 8 pieces are less than 9 pieces. So I know that this is less than. And no wonder I was having a really hard time coming up with my answer. We were only 1 piece off. So it really was too close to tell. Let's take a look at what we just did with fraction bars. We have 4/6 and we're comparing to 12ths. So by multiplying 4/6 by 2/2, I found an equivalent fraction with the same denominator. So here you can see that those two fractions are equivalent. By changing the name, we can easily find our answer, because at this point we have the same denominator, and so we know 8 pieces are less than 9 pieces. So this strategy is called creating a common denominator. Let's look at another example before we start our practice pages. So here I have 3/10 compared to 2/5. The denominators are not the same, the numerators are not the same, and if you think about how big or small these fractions are they close to 0? Are they close to a half? Are they close to a whole? 3/10 is just 3 pieces away from 0, 2 pieces away from the half, so it's between 0 and a half, kind of right in the middle. And 2/5 is less than half. It's 2 pieces from 0. These are both really close to each other. This is the perfect example of a time when I would want to create a common denominator. So that's the strategy I'll be using. Now, if we look at our denominators, are they related? Do you notice anything with 10 and 5? So I could take 2/5. I know that 5 times 2 equals 10, so I can multiply by 2/2, and that will give me a denominator of 10. What we're doing is we're purposely changing the name so that this fraction has that common denominator. So 2 times 2 is 4. Now we have a new name for this fraction. It's 4/10. So I can even cross that out and put 4/10 up here. It's really easy to compare 3 pieces to 4 pieces. So this is less than. Let's look at the fraction bars. So we had 2/5, and we noticed that 5 times 2 equals 10, which would be perfect for finding an equivalent fraction. Two fifths times 2/2 equals 4/10, so these are equivalent. And now we're comparing 4/10 to 3/10. So let's get started on our practice pages.